So today we are going to continue on with derivatives of trig functions. Yesterday we looked at just the derivatives of sine and cosine, and we know that we have the derivative of sine is cosine and the derivative of cosine is negative sine. Just a reminder about our Pythagorean identity from grade 12 trig that sine squared plus cosine squared is 1. And again, we have those reciprocal trig functions at the top. We're going to need those for today. So we're going to go through on the first page using product rule and quotient rule to try and find the derivatives of the trig functions we don't know the derivatives of yet. Um, Once we do that on the back of the notes or the second page of the notes, we will see that there's a little list for us. So you could memorize those, or you could just know that you can find them using the rules that we already have. Again, in university, they would not be giving those to you. And if we had a traditional test, you would not be given those. But while you're going through your notes and stuff, have those out. Realistically, sine and cosine are the ones you're going to deal with most. They are ones you should absolutely make sure that you know by heart, the derivative of sine and the derivative of cosine. So we're going to use those two to find the derivatives of the other four trig functions that we don't know our derivatives of yet. All right. So the first thing I'm going to do for everything, which is what I always do when I'm doing trig, is change everything to sine and cosine. So I'm going to first rewrite y as sine x over cosine x. And we can see that this is a quotient where the top would be our f and the bottom would be our g. And we're going to use quotient rule. Which was y prime is equal to the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So if I go through and do this, this means that y prime is going to be the derivative of the top, which is cosine x, times the bottom, which is also cosine x, minus the derivative of the bottom, which is negative sine x, times the top, which is sine x, all over the bottom squared. And now we're going to just fix this up a little bit. I can rewrite this as cosine squared x plus sine squared x all over cosine squared x. Our Pythagorean identity tells us that cosine squared plus sine squared is 1. So this gives us 1 over cosine squared x. We can leave it here and write it as this, or we can write it as secant squared x. Usually the textbook will write it as secant squared, just as a heads up. Okay. For the next one, same thing. I'm going to rewrite in terms of sine and cosine. I'm going to write this as 1 over sine x. Again, I can use my quotient rule. My f is the top, my g is the bottom. This means that y prime would be the derivative of the top, which is 0, times the bottom, sine x, minus the derivative of the bottom, which is cosine, times the top, which is 1, all over the bottom squared. If I fix this up, this gives me negative cosine over sine squared. Again, we can leave it like this, or we can rewrite this as negative cosine x times cosecant squared x if I want to bring that sign to the top. The other way I can write this is actually rewriting this. If I write this as negative cosine x over sine x times 1 over sine x, this is the same as saying negative cotangent x cosecant x. Any of these three is okay. So I'm going to ask you to try the next two using the same process. Pause your video here, try the next two, and then come join us again when you're done. All right, if you are now back with us, again, we're going to rewrite as sine and cosine, and we can use quotient rule. Derivative of the top is 0 times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Fix up the top. This is an appropriate answer. If you got this answer, this is fine. You can also rewrite it so the cosine squared is now its reciprocal identity, and you would have secant squared. Or you can write it knowing that sine over cosine is actually tangent, and then you'd still have one cosine on the bottom, leaving you with one secant. Any of these three would work. If you made it to the other one, again, I'm going to rewrite this. This time, this is cosine over sine. My y prime, derivative of the top is negative sine times the bottom minus the derivative of the bottom times the top, all over the bottom squared. On the top, I can rewrite this as negative sine squared minus cosine squared. Now, some of you might get stuck here and go, well, now what am I supposed to do? But I can, again, factor out a negative on the top and have a Pythagorean identity left. This leaves me with negative 1 over sine squared x. You can leave your answer here, or you can write this as negative cosecant squared x. So again, you could choose to memorize all these, or you might choose to just know how to find them. So on the next page, you'll see these all listed. Okay. So the top two, again, you need to know. You must know these. Even in university, you must know these. Okay. The rest of them, you can choose to memorize or realize you can find using quotient rule. Again, as you're going through your work here, you're going to have this list in front of you so you can reference them. I don't even have these ones memorized. I would change everything to sines and cosines and deal with them that way. Um, Realistically, most of the time you're doing questions, you're going to be using sines and cosines anyways, but they're here if you need them. So let's try a couple derivatives here. First one, we are being asked to find the derivative of 5 sine x minus 10 tan x. So f prime would be our derivative. Again, when it says differentiate, this just means find the derivative. So we've got 5 times sine x as our first term. So our derivative of sine x is cosine x minus 10 tan x. So our derivative of tan x is secant squared x. Okay. You don't need the brackets. You can just write this as 5 cosine x minus 10 secant squared x. I just wrote the brackets so that you could see that the derivative of tangent is secant squared and the derivative of sine is cosine. Okay. No simplifying that needs to be done here. We just leave it like this. Okay. Realistically, if you really wanted to, you could write this as 5 cosine x minus 10 over cosine squared. Make common denominators and make it as one fraction. But I don't know why on earth you would choose to do that if you're not being asked to. Okay. The next one, g prime. We notice here that we have two functions. We have f And I don't want to call it G because the question's using G here, and H. So we need to do product rule here. So the derivative of the first thing, the derivative of cosecant, is negative cosecant x. Oh, that was a little messy. Let's fix that. Cotangent x, that's the derivative of cosecant, times tangent, plus the derivative of tangent, which is secant squared, times cosecant. So here we've got this is our f prime, and this is our h. This is our h prime, and this is our f. Okay. And then we can fix this up a little bit. We would probably want to maybe rewrite these as sines and cosines. We've got a cosecant in each term. So there's a couple different things we can do. We could factor out a cosecant and then simplify. But I find it easiest to change this into all sines and cosines. So cotangent is cosine over sine. Tangent is sine over cosine. And then we have 1 over cosine squared times 1 over sine x. Now, the reason that this is helpful is I can now see that I've got some stuff that can cancel out here. The cotangent times tangent, because those are reciprocals of each other, those cancel out. Many of you might look at that and just know, hey, cotangent times tangent. I'm timesing a reciprocal by the original function. That's going to equal 1. Now, when I get to this point, I've got a couple options. I can just rewrite this as negative cosecant x plus secant squared cosecant. There's a couple ways we can do this. So I can choose to rewrite. One option is to say g prime is equal to then negative cosecant x, because everything else canceled out, plus secant squared x cosecant x. I could leave it here, but probably what I should do is factor out a cosecant x and rewrite this as secant squared x minus 1. I can leave it like this. This is one option. Another option, make common denominators. If I make a common denominator, the left term needs a cosine squared. So this becomes cosine squared x, negative cosine squared x, plus 1 all over sine x cosine squared x. And I know that 1 minus cosine squared x, that top is a Pythagorean identity. This gives me sine squared x over sine x cosine squared x. And then what happens is my sine from the bottom cancels with one of my sines from the top. And I end up with g prime equals sine x over cosine squared x. I can leave it here. I can also write this as tan x secant x. So I've got 3 good options for answers, and any of those would be considered okay. All right. So last question of the day, we're going to be doing a find an equation with a trig function. So again, find an equation. We're looking for y equals mx plus b, where m is our f prime. So if I want to find f prime, I've got f of x is equal to 2 cotangent x. So f prime would be 2 times the derivative of cotangent, or 2 times negative cosecant squared. I could rewrite this as negative 2 cosecant squared x, but you don't have to, because we're going to be plugging in an x value soon. So at an x value of pi over 4 from the question, that's what we were given, we have f prime of pi over 4 is going to be negative 2 cosecant squared of pi over 4. Okay. Well, this is the same as saying, I'm running out of a bit of space here, f prime of pi over 4. This is the same as saying negative 2 over sine squared of pi over 4. And from my special triangles, hopefully if you did your review sheet, you'll remember that sine of pi over 4 is 1 over root 2. So this becomes negative 2 over 1 over root 2 squared, which is negative 2 over 1 over 2, which means that my slope is negative 4. Okay, at that specific point. Now, again, I'm running out of a bit of space. I apologize. I'm looking for y equals mx plus b. My y is 2. My m is negative 4. My x is pi over 4. And I need to find b. So this gives me 2 equals negative pi plus b, or 2 plus pi equals b. We can just leave it like that. So this means that we have y equals negative 4x plus 2 plus pi. If you want, you can find an actual number, but usually when we have pi, we want to leave it. Again, lots of questions, a couple challenging questions in there. If you want, try a couple. Have the grid from the top of the page here, this box with your trig identities available to you if you need it.